huh, I have a theory. You ever hear that before? Or, it's just a theory, right? Wrong. Let's actually talk about why a theory is not just a theory, or why, I have a theory isn't really what you think you have. Um, so let's talk about those. And then let's also talk about laws and facts and how they differ from each other. So, when going throughout the scientific method, you encounter these phrases all the time. Um, there's the theory of gravity. There is Newton's laws of motion. There are cold, hard facts, and so on and so forth. Well, what is the difference between these things? So, we hear these terms all the time. Um, they're thrown around in textbooks, they're mentioned all the time on social media. Whenever scientists are talking, you hear these phrases a lot, and they're used very colloquially. You can tell that my speech isn't always the best. Used colloquially um, during just general conversation. That being said, what's the difference between these terms? Well, we can actually split these terms up into two categories: hypotheses and theories, and laws and facts. So here's why we can do that. Hypotheses and theories explain why something happens, whereas laws and facts explain what happens. For example, let me give you an example of a law. If I hold up this pen and let it go, it drops. If I hold it up again, let it go, it drops. I can do that 1,000 more times where I'm at right now, and it would drop every single time. That explains what happens. But why does it happen? That's where theories come in. There's the theory of gravity that states that lighter objects are attracted to heavier objects. This pen, when I let it go, it is actually openly trying to attract itself. It is trying to go to the core of our planet. And if there was a hole right here that went all the way down to the core, and I let this thing go down that hole, it would eventually end up in the core. What's funny is once it ends up in the core, it stops falling. Um, so that being said, let's actually talk about the differences here. Why are hypotheses and theories different from each other? And how are laws and facts differ from each other? So, what's the difference? Well, let's talk about the difference. So, first off, theories versus hypotheses. Um, Both of these fall under the category of explanations as to why something occurs. They both explain why something occurs. They both explain why something occurs. But there is one major difference between the two. A hypothesis is untested, unproven, meaning the only thing that's holding up a hypothesis is prior knowledge. It's what we think will happen. Um, for example, let's say I offered a class at 2:30 in the morning and nobody signed up for it. I could then make the hypothesis that, well, nobody signed up for it in the morning because it was at 2:30 in the morning. Nobody signed up for it because it was at 2:30 in the morning, and nobody wants to take a class at 2:30 in the morning. So then I could offer the class at 2:30 in the afternoon and see how the enrollment changes. If the enrollment is better at 2:30 in the afternoon, I have at least some evidence that my hypothesis was correct. So a hypothesis is something, basically, it's a guess. It's a guess based on prior knowledge, but it is untested, unproven. Now, if we take that hypothesis, we throw it through the ringer, we test it, we get data, we analyze the data, and on the other end, the data says, hey, this hypothesis is true. You have enough data to suggest that your hypothesis is in fact valid. When that happens, the hypothesis gets a promotion. It now becomes a theory. So a theory is not a guess. It's not a, oh, maybe. No, a theory is actually something with a lot of scientific backing to it. It has a lot of of oomph to it. It is considered accepted. It is considered valid. It is seen by the scientific community as true and as legit. So when you say the phrase, huh, I have a theory, if you haven't tested it and you haven't, and it hasn't passed those tests, guess what? You don't have a theory, you have a hypothesis. Now, if you test it and it comes out the other end and passes with flying colors, then it's a theory. Then you can pop open the champagne and celebrate. But until then, it is a hypothesis. Until then, it is a hypothesis. So that being said, theories get a bad rap in modern day society. When somebody says, huh, it's just a theory. Actually, no. Theories have a lot of backing to them. They are accepted by the scientific community as true. They are seen as a legitimate conclusion with a lot of evidence backing it up. Not to get controversial, so I apologize if you're offended by this, but the theory of evolution. The theory of evolution states that over time, as things adapt to their environments, they change, right? That's the theory of evolution. Now, that is a very, 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 very simplified version of it, but we have a ton of evidence to suggest that that is exactly what happens. That is exactly what happens. So when somebody says it's just a theory, they're actually giving theories a bad rap and an unfair rap. So theories are actually something that are very, very, very well supported. Now, how does that differ between laws and facts, however? So theories and hypotheses explain why something happens. Why my pin fell when I let it go. Laws and facts, on the other hand, explain what happens. So laws and facts explain what happens. Theories and hypotheses explain why it happens. So without further ado, let's talk about laws and facts. So a law is a generalization of how something will behave. When I say a generalization, what I mean is there are exceptions. There are exceptions, but in general, most cases, this applies. A good example of this are Newton's laws of motion. There are three laws. There's the law of inertia. When an object is in motion, it stays in motion unless acted upon by a force. There's F equals ma. And then there's, for every action, there's an equal and opposite reaction. Those are Newton's three laws of motion. But if the system that we're talking about is either really tiny or moving really, really, really fast, like close to the speed of light, those laws break down. They don't quite work that way. So while Newton's laws apply in 99% of situations that we would ever deal with, there are exceptions. There are exceptions. Just like the speed limit. I always like to joke with people about the speed limit. The sign on the freeway says 65. Are people driving 65? Usually not. Usually not. If you try driving 65 on the freeway when it's wide open, people are going to honk at you, flip you off, flash their brights at you. It's all a mess. How do I know that? I've experienced it. So those are laws. Now, what about facts? Well, a fact is an objective and indisputable observation, meaning it is true regardless of your point of view, regardless of your age, regardless of your values, regardless of your gender, regardless of your race, regardless of all those different things that describe how we look at the world, it is an indisputable fact. Um, I am currently sitting in an apartment in Campbell, California, in the United States of America, in the continent of North America, um, at 6:40 p.m. At least that's what my clock says, Pacific Standard Time, on January 29th, 2021. That is a fact. You are currently listening to this lecture as a part of Meteorology 12, whether you're taking it at San Jose State or De Anza College. That is a fact. You are listening to this lecture for that class. Indisputable and objective. So those are facts. Another fact, the sky is blue. You may call it something else. You could call it green. That doesn't actually change what it is. You may give it a different name, but the actual color of it stays the same. It's indisputable, it's objective. So that being said, how are theories, laws, facts, and hypotheses used to make valid scientific conclusions? And how are they sometimes abused? We'll talk about that next time. We'll talk about that next time.